Good morning, ladies and gentlemen. This morning's breakout is big data, and what is it really all about? Our speaker was recently named one of the top 20 big data influenced by Forbes magazine, with more than 25 years of experience, HPC experience at Credit Research, SGI, and Sun Microsystems. Rich is known to many in the industry as the guy in the red hat. Please welcome the president of Inside Big Data, Rich Brueckner.
All right, can you hear me? Great. Well, thanks, folks. And I have the rather difficult task of following a much more articulate and smarter speaker. So I'm going to talk to you today about big data and make a few points about what we heard just earlier. If you'll notice, he spent about 40 minutes before he even mentioned the term big data, and he never even used the word cloud. So I think this talk will be a little different, but first I want to make the proper introduction. I gave a talk once in Taiwan, and they first told me, before you speak to the group, you must first tell them that you're unworthy of them, and then you have to make a joke. So I'm going to do that right now with one sentence. Hi, my name's Rich, and I work for the media. Okay, so this is my site. I also have a site called insideHPC, but this is Inside Big Data, and it's primarily written by myself and a data scientist named Daniel Gutierrez. So let's talk about terms here, because people tend to take big data as a literal figure, and big data is not just about size. So is a terabyte big data, a gigabyte, a petabyte, exabyte? Did you know that what comes after that is called a yottabyte? So it's all relative, and it isn't about the size, but when I explain what big data is to my friends who aren't technical people, I say big data is about using information for purposes other than what it was originally intended. And it has nothing to do with size. So for purposes of today, big data is about high-performance data analysis. And I come from the HPC world, supercomputers. These are giant machines that simulate the weather, car crashes, things like that, that are too difficult to model in a laboratory, so they use simulation. The good news is, for folks in this audience at the Convergence Conference, the worlds of big data and HPC are converging. And the power of supercomputing is coming to your organization. And that's what I want to tell you about today and where we are headed. So, what is big data really about? And I think it's about two things. The first one is money. Now, we got a great figure there from the previous speaker, Krish. The Internet of Things, just the sensors and everything that's coming online, could contribute 1.9 trillion to the economy. That's just one source of data. Now, for you guys, I think big data is about opportunity. People in the cloud space, data center space. This slide comes from SGI, and it should tell you that this growth of information is outpacing organizations' ability to deal with it. Someone is going to have to fill that gap, and hopefully that'll help fill the pockets of your shareholders. So what's the second thing that big data is about? Well, when I hired Daniel last year, I started reading his stuff, and I had been writing about big data for 2 years, and I suddenly found myself at a loss. I didn't really understand some of the terms he was using. And he did this one story about Bayesian Statistics, and this is the very root of where big data came from. This guy in the 15th century, Bayes, invented this thing called statistics that we know today. And anyway, here was his story. It was a tech tip of how to use that in your Bayesian. Okay, and I read this and I looked it up, and I had an aha moment. And it came from this when I looked it up. Bayesian probability provides a rational method for updating your beliefs. Now, for those of you that follow what's going on in Washington, you might not believe that this is even possible, that beliefs are just fixed. But here, this guy used numbers to help people update their beliefs. And so that leads me to my conclusion that big data is really about degrees of belief. Not just about what we believe around the world around us, but what we believe about the data and its validity. And some things have changed to make that possible. And it isn't just technology. So can I prove my theorem that big data is about degrees of belief? Now, when I first did this talk, there was a tweet that came out. And right below is the quote here. 12 words just changed the value of Facebook on the stock market by $18 billion. And it was just a sentence. It said, "We did see a decrease in daily users, specifically among younger teens." Now, the degrees of belief here is that big data's future depends on young people that are going to use the service and supply that growth that has made them such a meteoric success. Well, guess what? Teenagers don't want to be on the same social network as their parents. This should not be a surprise. And this is big trouble for Facebook, by the way, because they're going to other social networks like Pinterest and things like that. So, what's changed to bring about this big data thing? Because we weren't talking about this 10 years ago. We were talking about IT and cloud and even grid computing. But if you go back more recently than days, something, maybe in the last century or so, we used to get all our information from things like census data and samples. And we took out the junk data and we drew conclusions from that. Technology has changed that. Now we can look at all the data. And we've also, in our beliefs about data, we're okay with messiness in data. And data scientists, people like Daniel Gutierrez, who works for me, they need all that information. You don't throw out that part of your demographic didn't really fit in the survey, throw that information. No, you looked at n equals all the information. Now, when I was talking about opportunity, the big change here is there's no eminent domain in what we're calling big data. Oracle, companies like that, don't do well with unstructured information. They're slow. Technologies like Hadoop, which is a platform, open source, does a much better job. It's not a turnkey package. You have to do a lot with it to get it working right. So, as far as opportunity for business, this could be a $17 billion business, according to IDC, by the year 2017. A lot of money at stake. So where are we headed in this talk? What I want to do is kind of take a little survey here in this room. But do you guys believe the big data hype? Please show me hands if you believe. Okay, just a few of you. My plan here today is to move that belief-o-meter towards the belief side. And let's see how we do. So first, let me tell you about something called Upworthy and headlines that Krish mentioned, that every time Justin Bieber sneezes, there's a story. Well, people have designed headlines to get clicks, and there's no such thing as a bad click. And in this case, you might see a lot of stories, big data doesn't measure up, it's all hype. Always look at their agenda, because chances are, what they're really after is for you to click on the story and read the first couple of paragraphs, and they've done their job. Because I believe that big data is the most significant thing to happen to this planet since the internet. And I'm hoping that you'll follow me as I tell this story. So let's look at that last story. It was on ZDNet. If big data was so powerful, how come it can't predict the economy? We should be able to do predictive analytics and know which way the stock market's going, right? We've got lots of information. So I asked the data scientist this question, a friend named Rob Farber, who is a scientist at, he's been working with supercomputers for years, okay? And the fact that the stock market is about degrees of belief and all these other things that you can't really quantify it because it's a nonlinear system. So you have to keep in mind the nature of the data when you make assumptions. So how did big data get me here? I was writing about big data in 2010, and I saw this article in Forbes, and it said, oh, who are the big data influencers? And I went into the article to read. I thought, oh, I bet you my friend Henry Newman's in there. He writes about data storage. He's a great pundit. But then I found my name at number 12. Now, to show you how perceptive this study is, I called my mom about it, right? Hey, I'm in Forbes magazine. And she says, yeah, you're the only guy in there that instead of a photo, they have a cartoon character. So let's talk about some case studies, and we'll start with some of the fun ones that illustrate this idea that big data isn't about size. And I chose this because of the big sumo wrestlers. Big data techniques were used to discover that there was fraud in the way these matches were going, and only through big data could they have detected it. Now, the size of this problem, when they put it all, would fit easily on your hard drive. But it was from diverse sets of data that were never in one place and were never intended for a study like this. And what they found is that sumo wrestlers have to win a certain number of matches to stay professional. But when they were in these inconsequential matches against grand champions, that the underdogs were winning a lot. And what was happening, that they proved later with text messages, is that they were throwing these matches. The bigger guy, the stronger guy, would let the littler guy win so that he could remain a professional. Now, that's all nice and everything, but sumo wrestling is a part of Japan's cultural heritage. There's a lot of money at stake. A grand champion makes over $1 million a year. This is big business. And big data discovered that it was closer to professional wrestling in the US than what they thought it was, which was unencumbered competition. So here's another case study. How many of you do fantasy football? Anyone? A few people, right? This is huge business. When I looked at Forbes last year, it was estimated that $79 billion is translated all in this realm of fantasy football. A lot of people do it, 32 million at least. There's this website called Prediction Machine. And this guy that runs this, I interviewed him, you can see it on Inside Big Data. He models the entire football season, and he runs it 50,000 times after every play to predict what has changed every game all at once. So, okay, you think, well, is that any good? Well, when he puts out his list of who's going to win the Super Bowl and everything, Vegas pays attention and the odds change. Now, how did he do this year? Well, he said Denver was going to win the Super Bowl before the season even started. Now, okay, so maybe Peyton Manning had a bad day and they didn't figure that in. But big data makes this possible. Next case study is about mortgage fraud. And we all suffered the effects of this, right? They were giving loans to anybody with a pulse. And there are actually gangs of people that go around flipping houses to each other, and each time they do, they take value out of it. And it was a Russian gang in this case that was found through a case study at LexisNexis. The amount of money here involved, just in 1 year in California, is estimated at $864 million a year. Okay? When this all crashed, we all suffered. I happen to have lost a job at that time at Sun Microsystems. When the economy crashes, we all pay. And these criminals, it was hard to find them because there was no easy way to spot their relationships. But through big data, LexisNexis has an incredible database of, I think it's 270 million people are in this database. Now if your name's John Smith, they know that you're that John Smith that has the sister Mary. That's how specific this information is. It's a little scary. But through this database, they were able to spot these relationships of these Russian gangs that were flipping houses. And the last guy took the fall and defaulted. And 3-4 years later, he came back and started again, because when you do a mortgage through a broker, you only see who owned the house before, not the history. So this brings that all together, and it could have a tremendous positive effect on our economy. So another use case, it might be closer to home for you folks, is churn and telco. Now, I think it's Katy Perry or one of these gals has something like 50 million followers on Twitter, right? But if she tweets that she switched from AT&T because it saved her money, the churn from that could be incredible. And you and I, we have a circle of friends as well. This is very important information because maybe they don't make so much from me, but my friends and their friends, if they switch, that's a lot of money in the bank that telco was counting on. So this case study comes from Teradata. They're able to map out these relationships. And when somebody comes up complaining about, you know, my phone bill was too high or you guys screwed up, they can pull this up. If that person leaves, they can see the potential financial impact and maybe offer you a sweeter deal. Now, another case study is a little scarier in this age of Edward Snowden, but my friend David Bader at Georgia Tech used supercomputing algorithms for something that is going to predict whether or not you're going to Breaking Bad on the US government before you even do it. So there's something like 750,000 people in this country who have security clearance. Now, what they're using is not just watching these guys, what they're doing, but using algorithms to look at what time they logged in, looking for any change in patterns. And by the way, when you have security clearance, you volunteer to be monitored, so this isn't subterfuge, but it is Big Brother watching Big Brother. And if we look at the things like people going postal, this kind of study could save lives. Now I want to talk about HPC because I understand that you guys aren't from that world, but I've been in it since the beginning, since college. And there's these two camps, right? And supercomputing, which is, if you think about giant machines that predict the weather, is on one side, Venus. And then big data is Mars, but they're coming together. And there's very different ways the way they configure. The computer room you look at might look the same. It's just racks of servers, right? The way they put them together is different. For example, in HPC, we don't use hard drives anymore. Hard drives break. We boot from the network. In a big data Hadoop cluster, you have as much cheap disk as possible because that's how Hadoop works. So one can't simply just flip the switch and make your supercomputer a Hadoop big data analytics engine. So I said at the beginning that this HPC is coming to your world, and I'm sure users of PayPal, pretty much many people. So PayPal looks for fraud just like the credit card companies do, but they need to do it faster. Because if they miss, they have something like 750 milliseconds to decide whether or not that transaction is real or if somebody's hacked your account. They've brought in InfiniBand and HPC technologies to do the analytics in real time. And one of the folks from PayPal, basically, he said that this has paid for itself 20 times over since they did it 2 years ago. And they've saved, according to IDC, they've saved $700 million in fraud. So more about this, but you can see the particulars. They're using MPI, message passing, technologies strictly that you might use only in HPC to get this done. So let me just kind of dispel some of the precognitions here about supercomputing, because the world has changed. When I started at Cray Research in 1986, the guy on the left there, that was a Cray XMP. That was the fastest supercomputer in the world. It had 4 processors. It cost $30 million. You had to use refrigerant pumping through it just to keep it cooled. It sucked tremendous energy. Today, the fastest supercomputer in the world is Tianhe 2 in China. It is a massive machine. I got to go see it 2 years ago. Incredible technology that they're using for their defense department, but they also share it with the world for general science. But if you look at, the Cray XMP with 4 processors, this thing has over 3 million cores. And it performs at 33 petaflops, which is 10 to the 15th floating point operations per second. So this world has changed. Now, where is HPC going? And think of it as a bellwether for the technologies that you'll see in your data center in a few years. This slide came from 2 years ago. United States government, the labs, they kind of chart out where they want to go. If you look at some of the numbers on here, we want to be at exaflops, exascale computing, within the next 5 to 10 years. This is 10 to the 18th floating point operation. It's 1,000 times faster than where we are today, except it's going to be a lot harder. And in fact, I made an announcement today. My company just acquired a publication called the Exascale Report that writes exclusively about the technologies and software things that are going on in preparation for this. It's going to be a lot harder because you have diminishing returns. If you have a machine like Tianhe with 3 million cores, you can't just multiply that by 1,000 and get an exascale machine, because the electricity that it would take to run that machine, even if you could build it, you'd need the Hoover Dam to power it. Nobody could afford the annual power budget. So the exascale targets out there call for it to operate for about $20 million a year, which is 20 megawatts. Now, I was at Hurricane Electric giving a talk back in October, and they have close to that right in their building doing web serving and cloud operations. So that shows you how attainable that it needs to be, that it could be, somebody could afford to power the thing. So trends. What's going on in big data today, and why I say that HPC is coming, is that the high performance in high performance data analysis enables you to do something called real time. Hadoop and the technologies that you're probably most familiar with are batch processing environments, okay? You submit it, and it comes back, and you get an answer when you get the answer. Real time is looking at all the data all at once and getting real information as it happens, with new data coming in all the time. Now, the technologies enabling this are called in-memory analytics, and a number of companies are at the forefront of that. We heard a lot today about the Internet of Things and the data that's going to be streaming in. The only way to handle this is with supercomputing and make sense of it, because if you find out what happened a half hour ago with these sensors in this worldwide, that's too late. That's information that isn't useful anymore. So this comes from Intersect 360. They're an analyst firm, friends of mine that watch the HPC space, and now they're moving to big data. Again, think that big data is more than just Hadoop. It has different users, different kinds of applications, and in fact, big data is being used by over 67% of the supercomputing centers out there. It's actually coming this way. They're using Hadoop technologies to do their data analysis. And the important thing there is that as HPC comes to your world, look at what it's doing for the people that have it today. IDC did a study. They asked 400 some users of supercomputing what it meant to their enterprise. These are enterprise companies, not the national labs. 97% said it is indispensable. They could not compete without HPC. So that power is coming to your neighborhood. So in summary, big data is really about two things. It's about money, or we wouldn't really care. It's also about degrees of belief. And I just read a study yesterday from CIO Insight, and it said that 3/4 of companies surveyed don't have a decent infrastructure or plan to take advantage of their own data and use big data analytics. 3/4. That represents your competition. Your companies can be that 25% that take advantage of this, get better insights, and compete. So I'm a marketing guy at heart, so I always have a call to action. I'd like to point you to this book. Download it, read it on Kindle, whatever, by Kukier. Big Data, a Revolution That Will Transform How We Live, Work, and Think. This was the best book. I learned more from this book than I did in writing 2 years about big data. I highly recommend it. It uses real case studies. It's very understandable. It's not about statistics. Great stuff. Second call to action. I'm a writer. I'm a storyteller. I kind of incorporated these concepts into a sci-fi story that I wrote for another publication. And you can see the URL there. And I encourage you to read it because it brings everything together. So, how did I do? Did I move anyone's degrees of belief? One hand, couple? Okay, there's a few. All right, okay. I didn't say which way I'd move it. Okay, so I guess I'm supposed to ask you to fill out your surveys, and I think we have some time here. In fact, 14 minutes. Are there any questions from the audience? We have a microphone, I guess. Anyone? All right. Well, hey, thanks for coming. Enjoy the conference, and we'll see you next time.